In question 5, we're told a circle C has equation x squared plus y squared minus 20x minus 24y plus 195 is equal to 0. The centre of C is at the point M. In part A, we need to find 1, the coordinates of the point M, and 2, the radius of the circle C. The question carries 5 marks. The equation of a circle can be written in the form x minus a all squared plus now y minus b all squared is equal to r squared. This gives us a circle, centre a comma b, radius r units. So what we're going to do is go ahead and complete the square. So considering terms now in x, I'm going to have x minus half the coefficient, which will be minus 10, and then we will square that and subtract away now 10 squared. So that's minus 100. I'll now consider the terms in y. We'll have y minus half the coefficient, which is 12, and then we will square that term and subtract away 12 squared. We still have now the plus 195, and we will set this equal to 0. So what we'll have now is the following. We will have x minus 10 all squared plus now y minus 12 all squared. If I subtract 195 from both sides, add 144 and add 100, that's going to give me 49. So what we can say then from here, r squared is equal to 49. Therefore, we can say that r will be equal to the positive root of that, so the square root of 49. Therefore, we can say now that r will be equal to 7. So the radius is 7, and we can say now m, the centre of this, is going to now be 10, 12. So there are 5 marks. There's m, there is the radius. We're now told point N is the point with coordinates 25, 32. In part B, we need to find the length of the line MN. So this is just distance formula. So we can say MN will be equal to the square root, and if we consider now the x coordinates, we're going to have 25 minus 10, and we need to square that, plus now 32 minus the 12, and we need to square that. So we can say now that MN will be equal to the square root. That's going to give me now 15. 15 squared is 225. This is going to give me 20. 20 squared is 400. So we can say MN will be equal to the square root of 625. The positive root of 625 is 25. So we're going to have now MN is 25. We're now told the tangent to C at a point P on the circle passes through the point N. In part C for 2 marks, we need to find the length of the line MP. A quick sketch will show this should be relatively straightforward. We know that a tangent creates a 90-degree right angle with the radius. So if we have something looking like this, we've got now the radius, which is 7 units, and also we found out this distance from the centre out to the point N. So let's just label this up. This now is the centre, so this is M, this is N, and this is some point now on the circumference. Here is a right angle. We know that this is 7. We know this is 25. So we can say now that NP will be equal to the square root now of 25 squared minus 7 squared. You might spot this as a Pythagorean triple, and you can say that NP will be equal now to 24. So it's 24 units, as stated. 24 squared plus 7 squared now is 25 squared. So find the length of the line MP. The length of the line MP is 24 units. So 9 marks in total for question number 5.